Okay, this is the key for higher level paper 3, our 2017 version. So, extremely important. I know you're reading all these over and over again, but always pay attention. Section A today, you're going to be answering all the questions. Section B, you're going to answer only one of the options. And you guys are going to be doing option D. So after you do 1 and 3, just skip on down to D. Don't waste any time reading through these options A through C, trying to say, hey, I think that one looks easy. If you've done any work on any of the videos for option D, you're gonna do better on that. Trust me. Some of these might seem easy at first, but pretty quickly students find themselves, they get kind of bogged down. So remember, you want a pen and you want a ruler and a calculator for paper 3. And also, I just sent out, review the lab practicals. I sent out a paper rundown. I believe there's 7. Because they might ask you about one of those labs, or they will ask you about concepts in those labs during section A. So let's get started. This first question is about vital capacity. Kind of cool. I love how IB has this. It's I think an appropriate, timely topic, looking at athletic performance. Many of you are athletes. Everybody has athletic skills in them. And this is talking about forced vital capacity. So that's the maximum volume of air that you can expel after full inspiration, which is breathing in. So forced vital capacity, so the most you can breathe in, and then the most you can breathe out in 1 second. Okay, after you breathe in all the way. This kind of breaks it down for these different sports that you can see here. So the first question is, what kind of apparatus could be used to measure lung capacity? So there's several that can be used. One is a spirometer, which you breathe into it. It's a device. The tricky part with this is the spit you get. So it's been a while. It's definitely post-COVID. We haven't done this. This was written pre-COVID. They probably won't ask you about spirometers. They probably assume you haven't been doing that. It's my guess, but who knows? Maybe they will. You can blow. So the spirometer is a special electronic device, or there's different types, or it could be attached to a water tank. You can also just use a bag or a balloon, or a chest belt can be used as a proxy that kind of senses pressure. So that's one apparatus. Remember, 1 point. Always, pay attention to the number of points to use as a guide for how much of an answer you're going to give. So how would it be used? First, whenever you use anything, you calibrate it, and you want to be in the same position, like for the physiology labs. That was an important thing. Inhale as deeply as possible, then exhale as deeply as possible. You always want, different repeats. Ideally, 30 is kind of the gold standard. So that's the outline of how you would do that. Using that information just from the table, what's the likely impact of long distance running on pulmonary function of professional athletes? So just in general, if we look at all these things, these are different athletes. The highest is, running and swimming is pretty high for forced vital capacity. Now, if you look at the forced expiratory volume, not much of a difference, right? Short distance is the only real outlier. The rest are all pretty similar. And this is kind of surprising. Even non-athletes, right? They're pretty close. So long distance running increases force vital capacity, but not as impactful for the force expiratory volume. Oh, I kind of got distracted too. It's just specific to long distance running. So usually it's going to be specific when you look at these data tables. So what I didn't do, I should have done, just underline that when you're going through it. So here we got a bunch of pro athletes, 30 non-athletes. One other variable that needed to be controlled in the experiment, and here is a list. There's probably more. Just to make sure making sure the only potential difference is its connection between sports, different sports you play, and lung function. All right. Now remember, your test that I print out might not be as good, but the one you'll get at the lab on the day of the test will be good. So aerial rhizoids, you might not remember. Those they're kind of like roots. Bryophytes don't really have true roots. Near a shoot apex, so this is the top of the plant, the tippy top of the plant. Now it's asking you to calculate magnification, so this is where you're going to need the ruler. Measure, if it's just magnification, you're going to measure what the bar is. In this case it's 10 millimeters, and usually it's going to be fairly round numbers. And the equation, magnification equals measured over actual. So measured size over actual size. I kind of remember MMA, mixed martial arts, so MMA. So my measured size is 10 millimeters. My actual size is 200 micrometers, so I put that one over the other. But you see how the units don't match up, so you gotta make the units match before you can do the math, do the division. So what I decided was to turn the top into micrometers. And go by the Bad Summer Romance acronym. If you're going big to small, move the decimal to the right. And that's kind of what I did here. I went from a big unit to a smaller unit. So I moved this decimal point, which would have been here, to the right. 1, 2, 3. So that comes to be 10,000. Divided by 200 gives us 50. So that's the calculation. Sometimes they might leave out different. They might give you the magnification, ask for the actual or the measured. You just have to rearrange the equation using algebra techniques. Technique for focusing the light microscope. So that's the they're assuming you've used microscopes. So here's what you could say. Hopefully you all have something to remember how to do that. You place it on the stage. You gotta center it below the objective. Those are those things that you can spin around. Start on low power. You want the coarse focus knob to adjust the focus. Once the object is in focus, you can then use the fine focus to adjust. I don't really need to put about switching to medium power because it's just talking about focusing, so that's not important. But this is important actually. I think it relates. Remember, you can always adjust the light intensity to help get that focus. The light intensity can make a big impact on seeing things under the microscope. Of course, you need light to begin with, so also maybe make sure it's on. That's another step that I see cause issues. Advantage: electron microscopes, very cool, can see much closer up, but really expensive and bulky, and you can't see living things. So here are all some advantages to using a light microscope, the kind that we have in class. You can see living stuff. It's portable, cheaper. You don't have to be an expert to use it. Things that are moving, you know, living tissue can move. You can see all that with a light microscope. Color, you can see there's a field of view is bigger. All right, let's do one more. Yeah, we'll finish section A right here. So here we have a graph showing the mean chlorophyll concentration in Narragansett Bay along the Atlantic coast, 1971 to 2006. Field data, chlorophyll concentration shown below. Now, remember, chlorophyll, that's from plants. So you'd be thinking that. And the kind of plants that are in the ocean are phytoplankton. So that is some knowledge that might be helpful. So the question is, suggests a hypothesis. We see the levels decreasing steadily, right? We have this little outlier pops up, but overall it's decreasing over a substantial 30-plus year period, okay, 35-year period. So these are some potential hypotheses. The chlorophyll levels have dropped because there's fewer phytoplankton. Pollution, we might assume that pollution levels have increased, at least certain kinds of pollution like plastic, maybe certain chemicals. That has led to a decrease in phytoplankton. And also, as we know, climate change, global warming, that's having an impact on our oceans. So that definitely could be affecting the ability of phytoplankton to grow in the ocean. So those are some hypotheses that could be mentioned there. And here, remember, mesocosm, that's a sealed, some kind of sealed container that you put some plants and some animals in, some producers and some consumers, decomposers. Put that there. Producers plus consumers plus decomposers, in order to cycle everything, basically in a bottle, stick it in there, see if it works. So what are discuss advantages and limitations of using these mesocosms to study? So in a mesocosm, it's nice because you really control variables pretty well. You can do a lot of samples and replicate. You can collect that data continuously all the time. You don't have to go out to the field, get data. That's expensive, and you can't go out there enough to get. Well, you can try, but it's easier to get data anytime, any place, anytime during the experiment. You can get data. Now, the disadvantages, it's very difficult to take into account all the different variables in the natural environment. And natural conditions change. So whatever happens in that bottle, might not be the same thing that's happening in the natural world. Okay, so that right there is section A. Now we'll move on to section B.